Hello, BC Calculus students. We're ready to take a look at how to score 2018 numbers 1 through 3. Here of our free response. And so let's go ahead and let's take a look. Interesting question number 1 reads like this. I don't know if you remember when we looked at this, we actually looked at this question last year because this was both an AB and a BC question. This question here with our escalator is actually modeled off the AP reading. The inspiration for that was people that were waiting in line to get from one floor to another for the escalator at the AP reading when we were on lunch breaks and things like that. And so this is what led to this question. So let's take a look at how you should score it. So I'm assuming that you have done your work and that you are now looking at this as to how to score it. Some of you are still forgetting to write the score for each section, write the score by each question, and then write the total score out of 27 for the 3 up at the top. So make sure you do that. So part A, we want to know how many people enter the line for the escalator during the time interval from 0 to 300. And notice that is the top line of our rate equation right here. So to get the total accumulated change, we must integrate our rate function. So we see that for part A, it's 2 points. There is 1 point for having the correct integral, which is this 0 to 300 of our rate function. And it's fine if you enter what that rate function is, but you don't have to. You can enter this 44 t over 100 cubed times this. So you can enter this function here, or you can simply just have the r of t written because it is defined in the problem. And then if you actually can plug that into your calculator correctly and come up with an answer of 270, you get the second point. Okay, part B. Part B, what we have to do here is you have to not just consider how many people enter the line, but also the fact that people are leaving the line. So the fact on part B is you have to consider that the exit is this constant value of here. Now notice that is a rate, person per second. So when we look at grading part B, if you consider rate out, so we see that here and you're subtracting this 0.7 here, that's part of the rate. So if you can see an evidence that you considered, you have to remember it's not just rate in but rate out, you get a point. That's a soft point, pretty easy one. So if you go here and you start with the people, to get the whole answer though, you must start with the 20. You must then use your value that you found, your 270 here is what goes there. And then when you calculate this here, you get to a total of 80. So it takes all that, the initial value, the accumulated people in, and the accumulated people out in order to get the answer of 80. So that would be for your second point. Based on part C, this is pretty straightforward. It's just 1 point. Do you have the answer? Okay, so do you have the answer here? And the answer would be this 414.286 or 285 seconds. Part D is 4 points. It's got the most complexity here. So first you get 1 point for just considering the fact you have to consider for where the difference of the two rates is 0. Or you can write that as saying when r of t equals 0.7. So either some expression where the difference is 0 or where r of t equals 0.7. That gets you 1 point. If you identify the value of time being equal to 33.013, you get another point. For your answers, here, what we see is that your answers are going to be this, it's at a minimum at this time of 33.013, 4 people in line at that time, and in order for you to that's approximate. That's at 3.03. Your justification is this chart here. So you know that the minimum has to be either at a critical point or at an endpoint. So checking the values at both endpoints, which we've already found. checking the values at both critical points, which are both of these here. This one happens to be the maximum. That happens to be the maximum, but the minimum is found at the first one here. Okay, that would get you all 4 points. All right, now let's look at number 2. Number 2 is a definite BC question. So if we look here to see what the question looks like. So we have this boat investigating plankton, and we see that we've got this, this equation. And so we've got this, this density of the plankton in as far as this model goes. And I'm making sure that this is, yeah. Okay. So let's go ahead and let's look at how we're going to score this here. So first for part A, 1 point for getting the answer, which is that negative 1.179. If you have that, you get 1 point. And then if you can explain its meaning using units, requires units, you get the second point. The meaning is that at a depth of 25 meters, the density of plankton is changing at a rate of negative 1.179 million cells per cubic meter per meter. And that would be because of the fact that you're given a rate. This derivative here is the derivative of a rate. And so it's important. You have to be careful if the density is changing at that rate. So you have to make sure that you understand that it's the density that's changing at that rate. Okay, because the density itself is a rate. It's cells per cubic meter. All right, then for part B, you get 1 point for the correct integrand. That means you integrate 3 times your P of H function. So if you do that, you get 1 point, and then you get another point if you integrate correctly, knowing the correct limits, and you get to that value there, you get your second point. Part C, you get 1 point for your integral expression here. So for your integral expression, we are talking about this value here. This going from 0 to 30 of the total plus 0 to 30 to k. Okay, so that would be our integral expression. You get 1 point for comparing the improper integral. So recognizing here that these must be compared. And then finally, if you explain it correctly, that is the bound, which makes it less than 200 million, you get your third point. Part D, you get 1 point for your integrand. Okay, so knowing you have to take the derivative of x, this is our parametric expression here, plus the derivative with respect to y, and square those, and then take the square root of the whole thing. And so if you get this part here, you get 1 point if you knew to do the correct limits, and you get the total distance there of 757.459. That gets 456. That gets you your second point. All right, moving on to question number 3. So question number 3, the way you should score this, you get 1 point for your integral. That is knowing that you need to integrate from 1 to negative 5 of g of x dx. Or you could express it like this, make it a negative, and go from negative 5 to 1 of gx dx. Either one of those would get you your integral point. And then your answer is knowing about having your initial value and then making sure that you evaluate the sum, evaluate the areas correctly. You could leave it in this form right here. That's okay. But if you do simplify, you must simplify correctly to 25 over 2. Okay, part B. So if you split it at x equal to 3, you get a point. Recognizing that you have to split this and go from 1 to 3 and from 3 to 6. So you have to integrate those as separate integrals because those regions are defined by separate functions. So that gets you 1 point. If you correctly get the antiderivative of 2 times x minus 4 squared, so if you get this in these brackets here, you get another point. And then if you know how to evaluate everything correctly and get to this, which reduces to 10, you get your third point. And then part C, you get 1 point for your correct intervals. That's from 0 to 1 and 4 to 6. If you get both of those intervals, and you have to have both of them, you get 1 point. Now for your reason, I will say this, if all you have are the intervals, no reasoning whatsoever, it's a 0. So you must have reasoning, but in order to get the reason point, it must be good reasoning. And that is because it's increasing and concave up on those intervals, because then you have to establish here there's a relationship that f prime is equal to g of x, so that function is positive. Those are the intervals where it is positive and where it is increasing. So that's what you're looking at there. And you must establish the relationship here between f prime and g in some way that those are equal, and then you must have something to indicate that they are both increasing and positive, that our g function is both increasing and positive on those intervals. And then finally for D, you get 1 point for your answer, which is it has an inflection point at 4, and then another point for the reasoning. Notice if all you just say is x equal to 4, that's not going to get you your point. You've got to have some reasoning, but correct reasoning would be that the g of x changes from decreasing to increasing at an x value of 4. And you don't have to reestablish this relationship if you already established it there. But you do have to say that it's because g of x goes from decreasing to increasing at x equal to 4. Okay, so go ahead, score that out of 27, the total of it, and then go ahead, take a picture of your work and your scoring and send it in. All right, hope you guys have a good rest of your day. We'll see you tomorrow.